So now that we've talked about the executor completion service methods, let's spend a little time talking about how it's implemented under the hood. You probably have sort of ferreted this out from the discussion we did before, but I want to spend a little bit more time talking specifically about how it's implemented. And it's pretty cool because it also shows a bunch of other interesting Java classes that we'll talk about later and are useful to know in their own right. So internally, the executor completion service uses an executor to run tasks asynchronously in a thread pool. So you can see here the constructor of executor completion service is given something that implements the executor interface. So that means it's got an execute method defined on it. And you can also see that there's a blocking queue, which sadly you can't modify. There's just one that it uses internally to queue up the results. And those have methods that we've talked about before in the context of things like the array blocking queue and the reentrant lock and the condition object. You have operations like put and take and offer and poll and so on and so forth. That's what a blocking queue does. And good examples of blocking queues are array blocking queues and link blocking queues. Client threads can process these operations asynchronously. So you can basically submit tasks and then get the results back as they complete. And here's how the methods are implemented. This is actually pretty cool. So we're going to take a look at the submit method that submits a task for execution. And in this particular case, it's going to submit a two-way task for execution. Remember that we typically ignore the futures that come back from submit. And the only reason that we get them back is if we want to cancel the asynchronous tasks for some reason. That's really the only reason we need to keep track of those futures. This version of submit submits a two-way task, which means you get a result back. And here's what the task looks like. We looked at this before. Callable has a call method that returns something of type v, which is the parameter that we have here. You can see v is parameterized all the way through this abstraction. The first thing that happens in the submit method is there's a helper method that's called new task for. And what it does is it takes this callable, this task parameter, and it wraps it up in something called a future task. Now, we're going to talk about future task later. We'll probably talk about it next week, I guess, after we're done here. You can see what this particular implementation does is it goes ahead and it makes a new future task and stores the callable inside the future task. And a future task is a class that implements future. Actually, it implements something called runnable future, and we'll talk more about runnable future in a second. A runnable future, as we'll see, is something that it's a future that has a run method that can do some work. So we're basically wrapping up the task parameter in a future task, and that gets returned and stored in this local variable f. The default behavior of new task for can be modified by overriding the new task for method. Let's pretend like we don't care about how that works, but that's what you can do. Here's what future task looks like. Now, we're going to talk more about future task in a subsequent lesson, probably next week or at some point in the future. And as you can see, a future task is a class that implements the runnable future interface. And the runnable future interface, as the name suggests, implements runnable and implements future. So from future, it gets the future methods like get and cancel and so on. And from runnable, it gets the run method. And here's what the run method of future task looks like. You pass a future task a callable, and that is what gets passed here to the constructor. And that callable gets squirreled away in an internal field given the very obvious name callable. So we have a field inside a future task called callable. And when the run method gets called for an instance of future task, it turns around and it forwards to the callable's call method, which will then block and give the result back. And assuming all goes well, assuming that we don't get an exception and so on, what's going to happen in the run method of future task is the done hook method is called. And the done hook method is something we'll talk about later. By default, the done hook method is just a no-op. It doesn't do anything. But you can override the done hook method to do other things. And assuming everything goes well, the done hook method is called. So here's what runnable future looks like. It has the run method. That was the method that was defined right there. And so we get this thing back as a runnable future. Okay, so now we take this runnable future and we encapsulate this in a queuing future. So now we've got like a Russian doll stack of nested tasks, if you will. So remember, we started out with our callable, and we encapsulated that inside a future task. And now we're going to take that result, and we're going to encapsulate that inside a queuing future. And each of these things does something else. It's kind of like the decorator pattern, but it's pretty interesting. So what we finally end up with here is a queuing future, and that queuing future will then be executed by the executor that's associated with the executor completion service. So let's see what queuing future does above and beyond what we get out of the box with good old future task. So a queuing future is a future task, and you can see that what it's going to do is it's going to go ahead and take the runnable future, which is this guy, which came from this. It's going to take that and it's going to go ahead and pass that parameter in as the parameter to the queuing future constructor, which will then turn around and store the task, this thing, in a local field. And as you might expect, the run hook method of queuing future will basically be this method, which will basically do this. It'll call the call method on the original task. This is very much levels of indirection gone awry, or gone berserk. So basically, we're storing this thing in the task field. The run hook method, which we inherit, is going to go ahead and dispatch the call to call. And then, when everything is done, remember the method here calls the done hook method. Well, the done hook method here is this method, and the done hook method will then add the task after it's finished completing successfully to the completion queue. So it adds the completed future to the completion queue upon the successful completion of the call to call. Now, it's very cool to understand all these things, but it probably gives you a deeper appreciation of why you just want to use this freaking framework and not worry about all these details, right? These are implementation details to let you see how it all works. And it's very cool, but it's a lot of accidental complexity. And quite frankly, had Java had better support for lambda expressions and method references back in the day, they would have cleaned this up quite a bit, and it wouldn't have been quite so layered and indirect. But that's basically how things work. So when this gets executed, it goes ahead and calls the call hook method. That calls the done hook. And then the done hook adds the task to the completion queue when it's all finished. Submitting a one-way task is the same sort of thing. It just doesn't have a result. Retrieving results, very, very simple. It's almost obvious. The take method will simply forward to the completion queue's take method, which will block until there's a new future available, which is then retrieved and removed from the queue. The poll method just forwards to the completion queue poll, which will either return a result if there is one or return null. And then poll with the timeout waits for that specified amount of time to see if a future is available. And if there is not one by that time, it gets null. Otherwise, we get one back. So the long and the short of it is that this allows one or more client threads to submit tasks, which are processed by one or more threads in the executor thread pool. And then one or more threads can wait to process the results as they complete asynchronously. So very cool, very, very concurrent. And that's the end of the internals.